Chapter 6, Lipids, Screencast 1. Now, before I really get in depth on this chapter, I want to start off with a couple of qualifications, and I think it really is important. When we're talking about nutrition, probably one of the most important concepts is moderation. I really do not like using the terms good versus bad and so on because, once again, the key thing here quite often is moderation. Now, fats especially have been vilified in the literature, but what we need to keep in mind here is fats are essential. They are necessary for our body, they're necessary for normal function, and once again, they are an essential nutrient, but they are vilified. Now, when it does come to using the term bad and fat, there are two times I will use that term, and it will be specific to saturated fat and trans fat. Both of those are well documented to increase the progression of cardiovascular disease. So yes, that's one of the few times I will actually use the term bad, and especially here, moderation is going to be critical. Now, let's take a look. Once again, we introduced this in the previous chapter, and it's based on my plate. And on the x-axis, what we have are different examples of food. And then on the y-axis, we're actually looking at energy from fat. And once again, they're using the colors from my plate overall. Now, unsurprisingly, if we look at the first two, vegetable oil, and we're also looking at butter or margarine, 100% of the calories are derived from fat. And notice as we go across, we're starting to see a decline. We see avocado being relatively high, so approximately 82% of the calories there are fat, mixed nuts, and so on. And then we work our way down to fat-free milk, cereals, and things like that. Now, if we look at chicken breast, very, very low end on the spectrum here, and they're looking at a 3-ounce serving, which is a typical serving when we are looking at meat and so on. But once again, I want you to get an idea, and this is a good cross-section of where we find fat in our food and how much of the energy from a particular food item is derived from fat. Now, triglycerides are the most common type of fat out there, and it's generally what we are ingesting. Now, we're going to see fats and oils. And fats are typically something that's solid at room temperature. Oils are going to be liquid. And they do have something in common with carbohydrates. They're made up of carbon, hydrogens, and oxygen. Yet in this situation, we're looking at nonpolar covalent bonds. Hence, they are not water soluble. Now, the family of fats is based on triglycerides, which are the most common, phospholipids, which play an important role in physiology with regards to cell membrane, and then we have sterols, which are derivatives of cholesterol, and the majority of them are going to be steroids. Now, the most common type, as indicated before, are triglycerides. So we find them in food, and that also is how we are going to store fat in our body. Now, the structure of a triglyceride is important, and this is something that I want you to keep in mind here. A triglyceride is made up of 3 fatty acids. So these are long carbon chains attached to a glycerol backbone. Now, the fatty acids do not need to be the same. They can be different. Another thing that's going to be important when we start talking about saturated versus unsaturated, we're going to see that that term is not a pure term, and we'll actually see a mix of that term, and we'll look at some examples along the way. Now, molecules of water is going to be released when fatty acids actually bond to glycerol, and that's the esterification process and how triglycerides are actually formed. Hydrolysis is going to be the reaction that releases fatty acids from the glycerol, and the term you're going to see here is free fatty acid. Now, a diglyceride, that is going to be a triglyceride that lost a fatty acid, a monoglyceride, 2 fatty acids, and reesterification is reattaching a fatty acid back to glycerol. So a very dynamic process of going back and forth when we start looking at triglycerides overall. Now, the previous slide kind of introduced these terms. So esterification, hydrolysis, and reesterification of glycerol and fatty acids. So triglycerides, once again, are built from a glycerol backbone, and we can see that here, and 3 fatty acids. Glycerol has 3 carbons in its chain, and what we're going to see, a triglyceride is formed when each hydroxyl group on the glycerol backbone bonds with the hydrogen atom from the carboxyl end of a fatty acid. Now, carboxyl is the acid end. Okay, so let's make sure that we're comfortable with that and that. So the bond between a fatty acid and glycerol is called an ester bond. So 1 molecule of water forms each time an ester bond forms. So this is that process of esterification. So when a diglyceride attaches to a glycerol backbone, 2 molecules of water form. Similarly, forming a triglyceride will generate 3 water molecules. So esterification is one of those condensation reactions which result in the formation of water. A molecule of water is used when a fatty acid breaks away from a glycerol backbone. So this hydrolysis reaction is thought of as deesterification and reattaching that fatty acid back to the glycerol backbone, reesterification, once again producing a water molecule. So these chemical processes are very, very dynamic because one of the things that we're going to see, we break down triglycerides, but when we look at how they're stored within the body, we reassemble them. So keep that in mind, and that's why I spent some time talking about this process, because it's a very dynamic breaking up, reforming, and so on. Now, when we look at the structure of a fatty acid, you're really looking at long chains of carbon atoms linked together. And remember, there's energy stored in these carbon-to-carbon bonds. All right? So fatty acids are a great way to store energy overall. Now, the other thing we want to keep in mind here is these carbon atoms are surrounded by hydrogen atoms. And that's where we're going to base the concept of saturated versus unsaturated. Now, when we look at a free fatty acid, we have an acid group, and that's the carboxyl group. We've kind of talked about those previously on one end, and then there's a methyl group on the other. Now, the carbon chains can vary in length, and they can be different based on the number of carbons, the degree of saturation, and then the shape. So a couple things to keep in mind when we're talking about the structure of triglycerides. Now, I'm not going to spend a lot of time focusing on how strict we are about defining numbers. So on an exam, I'm not going to have you know that 6 to 10 carbons is a medium chain fatty acid and so on. Okay, we do have some examples here. So a long chain fatty acid, typically 12 or more carbons. Our plant oils are a really good example. And then a lot of the red meat, so beef, pork, lamb, and so on. Medium chain fatty acids, those are going to be made up of 6 to 10 carbons. And coconut and palm oil are really good examples of medium chain fatty acids. And short chain, fewer than 6. And probably the best example here is a percentage of fat found in butter. Now, the number of double bonds is going to determine whether or not we have a fatty acid that's saturated or unsaturated. Now, fatty acids can fall under those categories. So saturated, monounsaturated, in which we find 1 double bond, and polyunsaturated is going to be more than 1 double bond, and we'll see what that is. So remember, carbon can bond 4 bonds, oxygen 2, and hydrogen 1. So this results in the ability to form these long carbon chains. So here we have a saturated fatty acid. And notice, okay, we're not really looking at the carbons in the carboxyl group or within the methyl group. I want us to look here and notice there's no double bonds. Okay, every carbon-to-carbon bond is actually a single bond, and we don't count the double bond in the carboxyl group. Okay, so it's just in the carbon chain. And there we have a fatty acid. And what's characteristic of these, they are going to be relatively straight and rigid. Now, monounsaturated, so now we actually have a double bond, and we can see that here. So this is a monounsaturated fatty acid. And here now, because there's more than one, we have a polyunsaturated fatty acid. So the degree of saturation is based on the number of double bonds that we find in that carbon chain. Okay, so that's important. I want to make sure that that is something we're comfortable with. Now, the shape. Now, this is also going to be important. Saturated and trans fatty acids have straight chains. Now, trans fats, and you've heard of those previously, and as I started off, they are bad, okay, along with saturated. And what we're going to see here, a trans fat has the hydrogens found on opposite sides of the carbon chain, okay? And so if I look at the cis form, we can see this here, okay? And what we see is, excuse me, the hydrogens are on the same. Trans, notice where the hydrogens are. They're on opposite ends of the double bond. And so that's really what we see. Now, when we talk about the creation of a trans fat, that's not a natural process, okay? Now, when we look at the unsaturated cis fatty acids, that results in a bent chain, okay? So the hydrogens found are on the same side of the carbon chain, and examples of these are going to be oils from nuts and seeds. Trans fats, as I indicated before, have hydrogens found on opposite sides of the carbon chain, and they are produced through a process of manufacturing. You may see the term partially hydrogenated. So hydrogenation is the process that's used to convert a cis unsaturated fat into a trans fat. Now, as I said before, the process of hydrogenation. And so what's happening here is you're adding a hydrogen to the carbon chain of an unsaturated fat. So what happens through this process, the chain becomes more saturated and it becomes solid and straight. So a characteristic of our saturated fats is to be more solid in nature, okay? Now, essential fatty acids, these are those cannot be made in the body, all right? And the two examples that we have are going to be alpha-linolenic acid, so that's an omega-3, okay, and we can see that here. And then we have linoleic acid, and that's an omega-6 fatty acid. So they're both polyunsaturated, okay? When we look at omega-3s, probably the best example are going to be fish oils, okay? So that's something to keep in mind overall. And I'm not going to go into the process and how we name them, okay? But it really is based on where the first double bond is located. So the omega-3, it occurs after the third carbon, and in the omega-6, it's after the sixth carbon in the carbon chain. Okay, so that's really, when you hear that term omega-3 and omega-6, it basically is referring to where the first double bond is. And remember, essential fatty acids are all polyunsaturated. And also remember that our body does not have the capacity to produce these. Now, when we look at why they're important, so we have our essential fatty acids. And so what I want us to kind of take a look at here is overall the pathway of omega-3 versus omega-6. So omega-3, remember the alpha-linolenic acid. And then we're going to look at a couple of things. But what I want to point out here is basically our eicosanoids are derivatives of these essential fatty acids. Okay, that's important. And what I want us to keep in mind here is these eicosanoids are basically local chemical messengers. Okay, so that's generally how they work. And many of them are involved in the inflammatory process. So very, very important when we talk about the need of essential fatty acids. Now, when we look at food sources of triglycerides, typically we're looking at animal fat and vegetable fat. So they are primarily triglycerides. If we look at some items such as breakfast cereal, breads, and fat-free milk and yogurt, they contain little to no fat. And there are some fruits and vegetables that are actually low in fat also. So if we look at coconuts, avocados, Those are going to be some examples. But generally speaking, when we look at fruits and vegetables, they tend to be especially low in fat content. Now here, what I want to kind of point out here are going to be a couple of characteristics of our fatty acids. So if we look at saturated fatty acids, what we know about these is that they increase blood levels of cholesterol. And as I've indicated before, they are bad. All right. So if we look at long chain, really good examples are going to be lard. All right. The fat that's found in beef. So there's a reason why that well-marbled ribeye steak kind of melts in your mouth. Okay. It's very high in fat. And then if we look at pork and lamb, so they're going to be solid at room temperature. Now these medium and short chains, so milk fat, coconut oil, palm oil, they're going to be soft, okay, or some actually might be a liquid. Now, when we look at monounsaturated overall, we do know that quite often these will be called the good fats because there's evidence that they actually decrease blood levels of cholesterol. So examples of monounsaturated, they have a single double bond, are going to be olive oil, canola oil, and peanut oil. And oils typically we're going to refer to as being liquid. Then we have polyunsaturated fatty acid. These also are found to decrease blood levels of cholesterol. They're going to have 2 or more double bonds. And if we look at some that are commercially available, sunflower oil, corn oil, safflower oil, and fish oil. So those are going to be examples of polyunsaturated fatty acids. Now, when we look at our essential fatty acids, okay, they basically have 3 double bonds. If I look at the omega-3s, okay, in particular, the best source are going to be cold water fish. So salmon, tuna, halibut, sardines, mackerel. Okay, and then we have alpha-linolenic acid, okay, and these are actually known to decrease the inflammatory response. So there's benefits here. They're going to decrease blood clotting and also plasma triglycerides. So walnuts, flaxseed, hemp oil, canola oil, soybean oil, chia seeds fall under that category. Now, when we look at omega-6, these are known to regulate blood pressure, and these will increase blood clotting. So we have to keep that in mind. They have 2 double bonds, and examples are going to be beef, chicken, eggs, safflower oil, sunflower oil, and corn oil. Now, trans fatty acids, there's evidence here that they increase blood cholesterol level, and they actually increase blood cholesterol more so than saturated fat. So what we're going to see here, their examples are going to be margarine, and that could be squeeze, tub, or stick. Okay, and we'll talk a little bit about the spread test a little bit later. Okay, and then we actually have shortening. So those can actually be soft to very solid when we're talking about that. So I think it's important to be well grounded in where fatty acids are coming from and their degree of saturation. Now, olive oil, we consider that to be a good fat. But what I want us to remember here, they're a mix of all. So we're not talking about something that's a pure monounsaturated when we talk about the fatty acids, and we'll see that in a second. Okay, so olive oil in particular is mainly monounsaturated fat. That does not mean you're going to see some fatty acids that are saturated, that you're not going to see saturated or polyunsaturated, but olive oil being characterized as a monounsaturated, that monounsaturated is most prevalent. Here, this is one of the things that I wanted to point out here, okay? And so if I look at saturated fatty acids, we're going to look overall, and notice we're going to see a little bit of all of them, okay? So saturated fatty acids, we're looking at coconut oil, butter, palm oil, lard, or beef fat. Okay, so as noted before, we tend to think of these as the bad fat. But notice what we have here. Primarily, it's the saturated fatty acids that are found in these food items. And we'll see maybe a little bit of trans. Now, I'm just going to bop down here to trans fatty acids. And you can actually see, even though they're derived primarily from monounsaturated and polyunsaturated, they're to a very high degree trans fatty acids, and notice where they are. Okay, then once again, what I talked about previously. Okay, you're going to see a mix in the triglyceride. Okay, but what it's made up of the most is going to be the overall classification of that fatty acid. Now, one term I think that's important is hidden fat. Okay, now I talked about this previously, but I don't think I addressed it as much. There are a lot of food items out there, and you're going to see low in fat, fat-free, but I want us to think about something. Okay? Fat adds a lot of texture and flavor to our food. Okay? If you take the fat away, okay, you take that away also. So one of the things that's done, if you have a food that's low fat, high fat, they had to add something to give it palatability. That's typically sugar. Okay, so I want us to keep that in mind. So quite often you'll see fat-free, chances are it's going to be relatively high in sugar. Now, hidden fat is that fat that we consider to be not visible. Okay, on meat, it's really easy. You trim that fat away. All right, but some examples are going to be whole milk, cheese, many of our baked goods. All right, hot dogs, crackers, French fries, ice cream, and this is where it's important to actually look at the food label. Okay, so here we're looking at these hot dogs. All right, 10 servings per container. Serving size is 1 link or 1 hot dog. And if we look at the calories, okay, so there's 140 calories per serving, but look at the amount of fat here. Okay, there's 13 grams of fat, and what we want to keep in mind here is there's 9 calories per gram. So if we look at the daily value, it's a pretty high percentage overall. And then also if we look at saturated fat, okay, so pretty high on the not so good fat overall. So reading food labels, especially with regards to fat, is going to be important. Now, previous versions of the food label put an emphasis on fat. Now, the new food label puts the emphasis on calories. It doesn't matter if it's a fat calorie, a protein calorie, or a lipid calorie. Okay? The typical problem that we have in the United States, not that it's fat calories, we're just getting too many calories. So that's why one of the big things that they did was really increase the font on the calories to bring the attention to calories per serving. Now, a number of things out there, there are some fat replacements, and the majority of these have not been all that successful. Generally what they do, they're going to replace the fat with water or protein or starch, fiber, a lot of different things. Some of the fats are actually engineered. A really good example is Olestra. This was used previously. You're not going to see this a lot. It was found in potato chips, and there were a number of pretty significant side effects associated with Olestra, and one of the common was very, very runny stools and diarrhea. Now, when we look at triglycerides, okay, remember we're talking about something that's essential. So we need to have fat in our diet for optimal health. Now, when we look at triglycerides in our body, okay, it's energy storage. Remember, I like to give a job to our essential nutrients. So carbohydrates are about providing energy. Triglycerides are going to be energy dense, and they're a concentrated source of energy. Lipid and fat actually acts as insulation, okay? And also it's necessary to help transport nutrients such as our lipid-soluble or fat-soluble vitamins. Now, what we do know that high intakes, especially of saturated and trans fats, and also getting too many essential fatty acids can result in a number of health issues. We'll be discussing those along the way. Now, as I stated before, triglycerides are energy dense, and this is something that you should be comfortable with. Okay, 9 kcals per gram is how much energy we find per gram of fat, And generally, our cells really are going to use fat for energy, especially at rest. Okay, so during rest or very, very light activity, 30 to 70% of the energy is provided by triglycerides. Okay, it kind of makes sense though. If I don't need energy right away, fats are big. Okay, it's not metabolically easy to break down a fat because of all of those long chain fatty acids, lots of carbons there. But remember, the energy is stored between those carbon to carbon bonds. If I've got a long carbon chain, there's a lot of energy stored in that particular fatty acid. It's not as easy to break down as a 6-carbon carbohydrate such as glucose. So it makes sense that at lower intensity levels, our body is going to utilize fat because it can. Okay? So there's that carbohydrate sparing aspect of things. Now, as I said, we're looking at energy storage, because if I look at carbohydrates and protein, they're basically 4 calories per gram. Now, what's going to happen when we have excessive caloric intake, once again, we're talking about the typical American diet, when they're in what we refer to as a positive energy balance. So they're going to have more energy coming in than being expended. So what's going to happen, typically, we're going to convert these items, because of they're in excess, we have limited capacity to store, into triglycerides. And as noted before, they're calorie dense, they can deliver more energy, and they also have a degree of expandability where they can expand. Now here, this is going to be important, and we have an adipose cell. Now remember, adipose is a connective tissue, and this is an adipocyte, and it's mostly a fat droplet. Okay, so notice here we have newly imported triglycerides. We'll talk a little bit about that. Okay, that are kind of embedded, okay, within that cell membrane, a nucleus, but the majority of this is a fat droplet. So what's happening here is these newly imported triglycerides are going to merge with that fat droplet. Now, as noted previously, another function associated with fat is to insulate and protect the body. One of the ways of measuring body composition is skin fold measurements. And what skin fold measurements are doing is measuring or estimating subcutaneous fat. So that is where a lot of fat is found within our body, okay? Subcutaneous. And that fat is designed to help keep the body at a constant temperature. Now, we also know about visceral fat, and this is fat that's found around the organs. This has a function of protecting our organs from injury and also cushions organs. Now, we also know that there are some health risks associated with where fat is found. So that's something we'll address in a future chapter. So visceral fat, that fat associated with organs, and also due to advances in imaging technology, we also know that there's intramuscular fat. So fat is located in various places within our body. Now, the other role that's going to be important with regards to fat is the ability to help transport and absorb fat-soluble vitamins. So those are vitamins A, D, E, and K. And so they're going to carry them to the small intestine and also help in the absorption of these vitamins. And then once again, fat-soluble vitamins will be transported via the bloodstream along with dietary fat.